Greetings, the Astro 30 here yet again, and welcome to part 8 of this variable lab power supply that I'm building. In this video I hope to finish its construction completely. That's rear panel, front panel. Second module will need to be built, which is just up the top of screen there in the background. Now what I've gone and done first is I've gone and made up a proper line cord for this thing, so I'm not doing the dodgy thing I was doing in the last video on this. Now it's a 2-prong plug, it doesn't have an earth, it doesn't really require an earth considering that's a double insulator transformer anyway, so it will have a inline fuse with the active though. That's currently not in connection at the moment because that needs to go across the back panel. So I went to JCar and I bought another one of those figure 8 terminated leads. I bought the 5 meter long one and I cut it down to roughly 2 meters. I stripped back the end of the insulation here about 250 millimeters, something like that, 10 inch. And I've made the active wire longer than the neutral wire on purpose because when I go to put the fuse in, the wire is going to be cut up here somewhere. This end that's now cut will join to the fuse holder, and this other end coming in will also join to the fuse holder. So the fuse will be in series with that lead. I left it long like this so I have enough wire to play with. I've got the multimeter set to ohmage across the power cord, and I'm going to turn the power switch on here, and as we can see, once the meter ranges, we've got 22 ohm there roughly. So I know that that's safe to connect up to the line, it's not shorted, and now we can move on to something else. And by something else I mean I'm going to change that large connector for the current measurement to one of these because it'll be a lot easier connecting it. I don't really want to lengthen the wire because it's kind of annoying to do that. This is not as, well, it's just as annoying. Man, that fart kind of stunk. Alright. So I'll see if I can desolder this. It should not affect the precision of the meter by removing this connector. I say shouldn't, but there is a lot of copper to heat through. I got it desoldered to a point, but it's very hot to touch. There we go, came off. Didn't really damage the connector either, that's good. So a quick visual inspection of the board. Doesn't look like I've overheated anything, so that's good. So I'll just grab my new connector and place that in the way around it goes. And the pitch is roughly the same, so that makes changing it so much easier. Alright, now this is probably going to take quite a bit of solder to solder, but I'll see what I can do here. And again, it may not. Well, it was easier to solder in than it was to desolder. Always the way. I must admit, these larger connectors are so much easier to crimp than the smaller versions. Right, so I now know that the current sense wire comes in at the top, because if I look at the original connector, the black wire is on top and the red wire is on the bottom, so I know the current flows in from the top and out through the bottom. So that means with this connector, this black wire, which is going to be my common input, has to connect there at the top. Now I'm going to use a green wire for going to the common terminal post on the other end rather than the red one. But it doesn't need to be as long. I'm going to make it probably 20 centimeters or so. So I'll do that, and then we'll just verify that the meter still works and is still precise with the current measurement. Otherwise I've just completely ruined the meter. There, like I bought one. Alright, I've yet to actually change this connector, but I will get around to that shortly. Now I'm going to set this up the same way I had before, same 9-volt power supply, just to verify that the thing still works. And I do not like this stupid positive wire. It's awfully hard to get a clamp on there. Alright, now if I connect this yellow wire to ground and my positive fell off. Oh, this is a complete fail. Stay on there. Is anyone else finding this amusing at this point? Because I'm not. Now, right. Yes, the meter still powers up. If I can get that to stay on there. Still saying 9.2 volt, that's fine. Now I'll just do a current check. So that means that that resistor goes there. That can come through my load. That can go there. That can now go to positive. 830 mA. It is still accurate, and actually it's actually increased to what it should be, which is 8.5. So it's got really slow ranging, but haven't damaged the meter. Right, now to change this stupid connector so it's got proper wires on it. Alright, that cable's done. I must admit, these connectors, JST connectors here, the smaller ones, those crimp pins are so small, they're harder to do than these ones. I ended up couldn't crimp these because, well, there was nothing to hold on to. So I ended up just tinning the wire, putting a drop of solder in the crimp, joining it in, and then using the pliers to actually crimp around the outside where it crimps to the insulation. So now this should fit into my meter. Well, it's supposed to. Well, okay. Let me have a look to see what I've done. I've actually found the method. Don't put solder in there at all. There was solder up the end of the red one, so it wasn't going to connect into the connector correctly. But I found if I just put this in this handy tool here, right down in the drawer of the alligator clip, and I strip off the end of my wire around about less than 1/8 of an inch and just lightly tin the end of the wire, and then come in with the pliers whilst holding the wire in there over the side, so it's pushing the two ends of both crimps at the same time to it, and then come back down this direction, so 90 degrees to it, and give it a good hard crank down on with the pliers, and it crimps fine. So this should, by rights, work now. Well, at least plug in. And you can always adjust the end of your crimp if it's not quite going to go fitting in there. Like a glove. Okay, that's ready to connect up to the power supply unit. Now I'm interested to see if all this work was worth it. I'm pretty sure you are too. So I'll just turn on my power. Interesting, I've got no power. Yeah, it helps to connect the the mains to the circuit board. That usually does help. Duh. Alright, let's try that again. There we go. Look at that. However, the display's flickering all over the place. I might have to change the filter capacitor that's on there. That's pretty bad. That comes off of that 47 microfarad 63 volts, so I can easily change that to a high value. Probably 470 would be better. But now with it on, I just want to see how hot that heatsink's getting. It's mildly warm, so yeah, that does need a heatsink. Alright, let's turn the load off. Interesting, when you turn the load off, the meter's more stable. So yeah, I think I need to just increase the value of that capacitor. Alright, let's put a load on the output. I'm going to use my 10 ohm resistor again. Positive. Negative. Alrighty. Turn the light on. And yeah, well, it says 89. 890 milliamps. Resistor is starting to get a little warm. Sorry. So if I went to 10 volt, like that, well, going on the tolerance of that resistor, it's saying 970 mA even though it's flickering. That is correct, or close enough. That is working beautifully, apart from that flicker. And that resistor's getting red hot. Okay, so I've proved that the current's okay. I should really see if it still current limits. So I'll set the current limit right down low. Okay, turn the light on. Oh yeah, limited down to 70 mA, 1.1 volt. Okay, I'm actually in current limit now. I should actually go out of current limit. There we go. Why don't we try that again? Alright, 40 mA and 70 mA and 1.1 volts. So current limiting is still working. Anyway, so what I should do now is I've lost my train of thought. So now all I've got to do is I've got to do the exact same thing I did on this meter to the other one. However, what I should do next is I should wire on the voltage pot, 10 turn pot that goes there instead of that, but I really do want to lengthen the wires. But it means I've got to change these connectors, and I don't have any more of these three-way connectors, so it'll have to go without for now. But that'll be done towards closer to the end of the video. So okay, so first things first, I want to try and remove or solve that flicker problem. So I'm going to start with a 220 microfarad 50 volt capacitor. I'm just going to simply touch it across these points here in the correct polarity and see if the flicker on the meter goes away, which it should because it's a high capacitance. Oh, cheap power board. Damn, man. Okay, we've got voltage. It's actually flickering worse. Alright. Where are we? There we go, flicker's gone. How about that? Right, let's change the capacitor. Okay, finally got it in there, now I can solder it in. Okay, let's see if we made a difference. Turn that off. Indeed, we have. Alright, so it needs to be a 220 microfarad 50 volt in there instead of the 47. That's alright. Well, it's been a few months now, I think around about 5 or 6 since I last looked at this power supply project, and it's one of those things that ended up being something that I ended up starting and never finishing, which always seems to be the way. But I'm going to finish it now, or at least by the end of this year. No, I'll be quicker than that. Anyhow, what I've got so far is I've replaced this adapter board with the newer version that I used in that 15 watt plus 15 watt stereo amplifier, mainly because there was a problem with it, with the way I had the capacitor across the switch. Still allowed, well, about probably a tenth, maybe a fifth of the voltage from the line into the transformer, which meant the LED on the power switch wouldn't extinguish. So that basically meant the transformer was live for all intents and purposes all the time. And speaking of the transformer, that's also now physically mounted to the case. So I've ground off all the crap on the ribs there that I don't need, and so it now mounts as flush as possible. Anyhow, I'm going to order the front panel to be made. It's going to be a PCB. I think I've already explained that in a few parts before this. But today, well, in this part of the video, what I'm going to focus on mainly now is fashioning the back panel. And yes, I do still have my other desk, but I'm using this more as a workbench. Now, I've been to J-Car and I've got one of these aluminium sheets, which is 18 gauge and a HM9500. And I was lucky today because this was the last one available. They didn't have any more than that. Although I don't remember these ever having rounded corners, but this one apparently does. Anyhow, so I need to cut a piece out of this 248 long by 76 high, or 248 long and 76 wide, whichever way you want to look at it. So it's going to be awfully difficult with a hacksaw. I could use a jigsaw to do it, but then again I've got no way of holding this flush or flat so it's not flapping around with the jigsaw blade, so it's probably easier to just do it with a hacksaw, even though it takes longer. So that's pretty much the way I'm going to cut it. I ended up going for the edge of the desk here because that means I can get my hacksaw blade in here without it interfering with the clamp. The one at the other end is not so much of a great issue because that is sort of off to the left there. Yeah, it's doable, it's just annoying at the same time. And I've got an old towel on the floor to catch any crap that may come off of this. Now this is going to take a while. This thing can't cut straight for its life. Alright, so I don't think I did too bad. We've got almost 246 there, almost 246 there. I think it was supposed to be 248. 2 mil too short, but it should still fit in the case. If I have to cut another panel, I'm going to be pissed. And it's almost 76 that way, almost 76 that way, 76. Alright, let's see how well I did. And actually, because it's actually not 248, it fits in there nicely. That's perfect. Let me get the lid and I'll verify what the total overall height is. So I've got the lid. I'll just plop him on. Oh, that's perfect. Yep, there's no issue, no gaps, and it's now a metal panel. I mean, the case is slightly warped, but that's just due to how long it's been sitting around for. So tune in next week when I actually drill the damn thing. No, I'm not serious. Yeah, so the next thing I do will be to mark out where all the holes go. From this perspective, I need 2 here for the fuse holder and the cable, power cable inlet, and of course the 6 holes per heat sink, I think it is, maybe 5 holes per heat sink for the transistors, regulators, the standoff adapters, etc. Yeah, that'd be 5 holes times 2, because I'll just mark out and drill the second one. Fuck my bum. No, I've got it drilled. This hole for the power cable is 10 mil in diameter, because this little cable clamp, which is designed for, it's the smaller one of the 2 that JCar sell, it's more designed for the 2-core double insulated cables. Needs a width of 10 mil before the chamfered part. I'll just have to round file out at the bottom and top just to make the clamp fit in there. The fuse holder is drilled out to 12 because it's another one of these type of fuse holders. All the holes for the heat sinks are drilled. Ignore this one over here with the really rough looking hole. It ended up countersunk, which it doesn't need to be. It doesn't matter, the little PCB standoff thing sits up against that anyway. That just happened because the drill bit grabbed into the metalwork and ripped into it, which is kind of a bit of a pain in the ass, so, but yeah, it is what it is. Luckily it's on the inside edge, not the outside edge. So now what I have to work on is this hole. So that's the next thing I'm going to be getting on with. And I've already taken the heatsink off of the working power supply module, so I could look, you know, visually look at where things went. It needs to come off anyway because this needs to go on that side. So it had to come apart anyway. Now, on to fixing this hole up. Well, being soft aluminium like this, or aluminum, makes it very easy to get it filed very, very quickly. So I'll put my cable in the cable grommet, preferably in the correct direction. Pass up, this is where you need 3 hands. Pass the cables up through the hole. I think I've got it roughly the right size. It may take a bit of squeezing with Z pliers, but I should be able to get that in there if I play my cards right. Alright. That's it. I had to file the hole a little bit bigger, but now it's a little bit loose. But the cable's not pulling through, so I'll just do the hot glue trick on that, just to make it stay where it is. Might as well put this fuse holder in too whilst it's just sitting here handily. And then I can go about wiring up the mains wiring to the fuse. Oh, come on. I actually do have a 1 amp fuse slow glow for this, because I think I did mention that I calculated the total transformer VA at 500. So it only needs like a 500 mA fuse, but 1 amp you always use double fuse protection, just to account for any inrush. Yeah, a little bit of hot glue will stop that from moving around. So there we go. There we've got the power cable and the fuse holder installed, and it's now starting to look like something. Okay, so I'm ready to do this mains wiring. So what I'm going to do is I'm going to line these two crimp connectors up to each other, follow the cable back to where it's stripped at the insulation, and then a tiny bit more because it's going to come out the centre point of the fuse holder. So I'm going to cut my mains inlet active wire about there. So there should be plenty of length to get to the circuit board and plenty of length to play with here. So I've got two options. I can connect this one here or here, because these are both electrically connected. This one is not. So I might do it probably to this end. Yeah, no, probably this end would be better. Alright, got a piece of heat shrink, got to make sure to put that on first. Otherwise I'll be wrapping that up in shitloads of electrical tape. And I don't really want to do that, so that can go up there like that. Solder him. I'm trying to solder sideways so I'm not in the way of the camera, which I tend to always seem to do. As long as it's soldered to the tag, that's alright. And indeed it is. So I can just trim this little dag off. It's really, really handy stuff. I'm glad they invented it, to be honest. Alright, got a couple of cable ties here, so I'm just going to put one around the top end, just to make sure that it can't accidentally slip, and one around the cable exit point, just to squash that bit of heat shrink down a bit. Which didn't appear to do much at all, but should be fine. Okay, cut that off. Cut that off. Now I'm waiting for the heat gun to, hot glue gun to heat up. So I wonder if this is hot enough yet. Yep, nice and hot. I mean, I like this stuff, but I don't at the same time because it's messy. Something on the fuse holder, just in case it wants to decide to spin on me. Ugh, what a mess. So I'm going to try and get some in there, and some around there. Alright, so I'll unplug the heat gun now. And I need to pop the fuse in, so I need to pop out the fuse center and find out what I did with my fuse. Where are you? Right there. Pop that in there. Pop it back into the fuse holder. Really? Really, you want to do that shit, do you? There's the outlet, that's the outlet, so... There we go, that was a bit more difficult than necessary. So, now I need to check for continuity through the power plug, through the fuse, etc. Make sure we got continuity, so I'll take into the cable. Neutral is there, so if I put it on the neutral lead, well, you'd think there'd be continuity, but there's not. What? Seriously, what? Because that's the wrong power plug. That's the right power plug. That was the hot glue gun's power plug. Let's try that again. Well, help me to understand. Why have I got no beep? There we go. And the live. No live? Yeah. We should have. Oh, yeah, okay. This fuse is not making very good contact. I reckon I might know what it is. It's that extra cable clamp I've got on here. I've had that issue before. That's probably why the fuse was hard to get in. So I stick the probe up the spade. Now we have continuity. That shouldn't actually move anyway. So I'm just going to check that I can get the fuse in and out properly. Yep, okay. So I won't put a cable tie on this side because it didn't like it. Alright, so I know that that's now electrically connected. Probably still could use shorter screws here, I guess, but yeah, don't suppose it matters. Unscrew one at a time. Then I'll do a fit in the case test and see if it fits. Then I'll test that the supply is still working after I've messed around with it. It should be, I mean, I don't see any reason why not. Okay. Alright, clears the transformer, so that's the main thing. It's alright. Alright, so I can move that round and plug that into this adapter board. Beauty. Alright. Get rid of these two circuit boards. Still need to finish this module. That should sit nicely up there like that without interfering with anything, which is good. Everything just fits. Alright, everything's hooked up. I'll just plug this in and verify that it works still. Everything should be electrically okay. Yep. 0 volts apparently, and oh, sorry, that's upside down. That's still got a connection issue. Anyway, there we go, 19 volts, 0 amps. This is the voltage pot here. 0 volts. 19 volts. It's up full for some reason. Okay, so I've got 5 volts there. Alright, let's have a look here. Yep, multimeter says 5.7. Display over here says 5.7. So yeah, that seems to be working. 7.4, 7.4, almost 0.5. Yep, beauty. Now I can turn my attention to the second module and, well, the front panel. Okay, so I'm still waiting for my PCB to turn up for my front panel. I was hoping it would turn up today, but it doesn't look like it's going to until Monday. So to continue on with, ignore that, to continue on with the project, I'm going to do the task of wiring this multi-term pot, rheostat, whatever you want to call this thing. Well, it's not really a rheostat because it's multi-turn It could be a multi-term rheostat, whatever you want to call it. Right, this multi-term potentiometer. Now, it's been months since I actually looked at it, so I've forgotten what the pin out was, so I've just measured it. And from left to right, when you hold the pot in this orientation with the shaft pointing to the right, which is pins 2, 1 and 3, so that's 2, 1 and 3. It's the center pin is this outer pin, the counterclockwise position is this pin, and the clockwise position is this furthest pin. So that's how I'm going to wire it. I could be completely wrong, but that's what I could ascertain with measuring it with a multimeter. I need to lengthen the wires anyway to the PCB. I do have 2 spare 3 position header plugs that suit those headers on the board. I have to do the current pot as well, make the wires longer, because it really needs to go around the transformer to the front panel with a little bit of, play there. So I get to doing that, put on some new wires, do up the connector, and then we'll connect, well, at least this one pot to the circuit board, and we'll see how much of a difference using a multi-term pot compared to a single-term pot actually has to setting the voltage. And there it is, wired there. I forgot how much I hate these stupid connectors. The JST ones, the smaller ones to these, are a lot easier to crimp for some strange reason, maybe because they're smaller, I don't know. These are just pain in the ass. I've got some heat shrink here on the end of the connections of the pot here, but I'm not going to melt them down to actually shrink yet, although they already appear to sort of be kind of attached, until I've actually plugged it in and tested it. Yeah, I don't think that's going to come back off again. So, well, whatever. Anyway, I'll bring the power supply unit over here, the project, and test it out. Alright, so I've got the unit sitting here. That's fine where it is. That's just the load switch, and that's the power switch. So I am going to have to shorten this cable because it's kind of a bit too long. So we'll unplug this potentiometer. I'm not going to destroy what I've done here. I'm going to keep hold of this for testing other things, including the second module, just to do a quick, does the voltage change test. So I'll grab my new potentiometer, and I will going to have to reroute all the wiring anyway, but that looks like it's going to be, plenty of material on there, and it'll just be cable tied to, well, the current pot, which I haven't done yet. So I'll just put this where it can be seen, and I will plug the unit in. Currently this is all the way anti-clockwise. Turn the power switch on. We indeed do have a display, and look at that, it increases. Now we're at 1 volt and I've hardly even turned the pot. That is a much more smoother and accurate way, or at least close to accurate, of setting the voltage. So say you wanted, I don't know, 9 volts exactly. So we wind the pot up until we get 9 volts. And as we can see, it's setting quite nicely. I do have to check the wiring though to this meter though, because there was an issue the other day with it. I'm not sure what happened, but yeah, whatever. It seems to be fine. So at least I know now that the pot is wired correctly. And when I actually put this in the case, I'm probably going to put it with the pins facing out towards the left rather than facing down, so it gives it a little bit better clearance. So that's the potentiometer wired up. I could probably put a cable tie there and one in the middle maybe too. I've got enough of these little bastards knocking about, so I might as well use the little bastards. So I'll just put one here, preferably the right way around. And just one in the middle, and I'm going to cable tie everything on that channel together anyway, so the current pot, output wiring, all that sort of stuff is all going to be connected or by a cable tie to each other, so it keeps things neat. So right, well that's that part done. I just need to duplicate this and do it a second time for the other pot, but I'll do that once the front panel comes. And I've also got to rewire the current pot, make it a little bit neater and the wires a little bit longer. Anyway, son of a bitch! Ran out of solder. Lucky I have a new one. Well, it looks like my front panels have now arrived. It is Monday now. Box is a little damaged in transit. I like what it says here though. Home casual clothes. Okay. Well, that's not what they are. Ho ho. Alright, let's get the box open and have a look. Now, I don't want to handle the PCBs too much because I don't want to get fingerprints all over the solder mask until I've actually spray painted a clear coat over the top to protect it. But I do want to find out whether or not the panel fits in the case properly without having to, like, you know, shave down the edges. It's a bigger box than what I normally get. Oh, doesn't that look sexy straight away? Look at that. That is, oh, better than I expected it was going to come out. There we go. Yeah, that looks pretty nice. Alright, so what I'm going to do is move over to the other desk behind me and check some fitment. Now, I might just make it easier and just disconnect everything out of the way so that makes it easier to maneuver the front panel around, because, well, this stuff is kind of in the way. I mean, it doesn't take that much to, like, hook it back up again, but I just want to do that. Now, I've done the current pot. I've also redone the limit LED, so all the wires have been lengthened now. I had actually had a couple of these spare 2-pin connectors, so I thought, well, I might as well use it. You go off to there and there, and just remove the output. Okay, well, that didn't work. So let's see. Yeah, it's a bit big. Yeah, it's a bit big. I'm going to have to sand the corner edges down a bit. That one's got an issue with the solder mask, so I might choose a different PCB. Lucky it's PCB material, it's easy to work with. Fits a little bit better now, and the lid fits on, so the case fits together reasonably nice. So that's cool. And it still comes apart, so that's also good. I guess it'd be a good idea to see if these panel meters fit in the provided holes, because if they don't, yeah, they'll fit in there just fine. Okay, cool. Now, I just want to check my voltage pot, make sure it's going to fit through the hole. Yep, and there's just enough clearance from the panel meter and my PCB for the power switch adapter. seeing just enough clearance, and that's not even all the way in there because the nut's still on it. For instance, the current pot, yeah, that'll fit in there just nicely. That's good. The LED hole should be 4mm, which it looks like it is, and of course the switches. This one being the power switch. Yeah, that'll fit in there just nicely. Okay, everything fits, so I might give the edges of this one more final sand, clean it up, and spray some clear coat protectant on it. And there it is, all there, nice and shiny and protected. Now, I've got an issue trying to get these panel meters through the hole because the hole's, well, the right size for this, but with the circuit board in there, there's not enough give in these clips because the LED displays are in the way. So I've just taken the board out of the shell so I can push the shell through. See, now it fits perfectly. And I'll do that to both meters, and then I'll just put the circuit boards back in. It's not that real much of a bigger deal. There we go. Get rid of the diffuser as well. Otherwise it's just going to fall out. There we go. I can turn it upside down. Put the diffusers back in the correct way up. And, well, I believe this is the right way around. If I get them backwards, I get them backwards. Although it wants to be a pain to go back in, so there we go, that's one. I hope I'm putting these the right way up, because if not, I'm going to be kind of annoyed. So what I might do is I might plug the meter back in and just make sure that it is indeed the correct way up. Let's see if I'm right or if I'm wrong. Huh, no, I'm right. There's the voltage, there's the current. So I've got them the right way up, so that saves me having to pull them back out. Okay, to continue on with the rest of the assembly of the front panel. I'm going to put the power switch in, even though it doesn't have an LED set of wires on it yet. In fact, I might actually solder them on, so at least they're ready to go. I do have a spare connector. Now what I'm going to do is I'll run the connection for the power LED off of the second module rather than off of the first module. The reason being is, well, the power switch is here and it's a shorter distance to travel to get to the connector. So I'll unplug it from the mains and I will get about wiring on the leads. I don't know if I'll do the connector end today. I've got to go out and buy some extra hardware to finish off the panel. I also need another $50–60 worth of components to finish this board, so this is going to be probably not completed in this video, but the front panel and the first channel, as well as the output connectors and limit LED, etc., are going to be completed with some knobs and stuff. So that's my plan. So I'm just going to unplug it from the mains before I touch that switch. Well, that's annoying. I can't find any cable ties laying around at the moment. I don't know what I've done with them. This is what happens when you move. You tend to lose stuff. So anyway, I'm going to put the power switch into the PCB, well, the front panel. It'd probably be easier if it wasn't connected to the rest of it. That'll make it a little bit more easier. I'm going to have to put some hot glue behind the back of these meter bezels because, yeah, they're moving in and out a little bit. It doesn't look too bad. Alright, I'll go about continuing to put stuff onto the front panel and come back. Check it out, it's starting to actually look like something. And notice one issue. The connector for this panel meter to measure the current is really close to that transformer tag. I've tried to bend it out of the way as much as possible because it does stick out quite a fair way. I did try that other plug in there and it is pushing up against the meter a little. There is not much I can do about that, unfortunately. However, it's starting to look cool, but that didn't quite work right. What happened? Oh, nothing's plugged in, of course. I had the voltage pot inversed and I didn't have the meter plugged in. So try that again. Here we go. Luckily the voltage pot was plugged across the meter connector because the center pin's not used, so there was no voltage actually flowing through the pot, which is good. And the pot still appears to work. The load switch works. The voltage, we're at 4 volts, and according to that we're at 3.991, which is close enough, I suppose. So yeah, power supply is still working, which is good. See, there's my clearance issue, but I'll get that out of the way. I reckon it'll just clear it fine. It's not putting any undue pressure on the panel, nor is it putting any undue pressure on the panel meter. I think that should be fine. I should have really thought about that before putting the transformer in. Oh well, it's starting to come on now. I've got the other set of controls. These are only just finger tight. The other load switch and some of the internal wiring for the second channel done. However, I'm going to leave this episode here, mainly because we're coming up to the 1 hour mark now, and it's yeah, I think 1 hour is just enough to digest for this. So I've made some progress, which has taken me 8 months to get there, but in the next episode, which will be the final one, I'll have the second channel built, test it, all the hardware and everything else. However, if you enjoyed this video, please remember to go down the bottom there and rate, comment and subscribe if you haven't done so already. Anyway, this is the Astro 30 saying see ya, and I'll see you in the next episode. Ciao.